It would be possible to make several videos about polar graphing, because there are a lot of intricate details that you need to understand in order to get the graphs exactly right. However, we're just going to focus on the basic shapes of these graphs. And so when we do polar graphing, we're going to be just playing a game of connect the dots. We're going to plot a few points and connect them together to get the rough shape of these things, rather than worrying about all the details, such as which tangent line it crosses zero at and things like that. And so when we look at polar graphing, we're going to think, well, what does that mean, connect the dots? Well, if you think about graphing something like y equals x squared, the most basic approach we had was that we made a chart of values, x values and y values, and took x to be like -2, -1, 0, 1, and 2, and then calculated y values for 1, 0, 1, 4, and then plotted those points on an xy grid. So x would be -2, y is 4, that's up here, -1, 1, 0, 0, 1, 1, and then 2, 4. And then we just sort of tried our best to connect these dots together. And that's how we got the basic shape of a graph. We're going to do the same thing, except we're going to have to do it in polar coordinates, which means instead of the xy grid like this, we're going to be looking at a polar grid like this, and trying to figure out how to make these points appear here and then how to connect them correctly. And so that's what we'll look at next. Let's look at an example. Graph r equals cosine of theta. Now remember, the r and the theta refer to some polar coordinates graph. But we're actually going to start off by looking at this in the xy plane. And the reason why is that this will help us think about the values that we're interested in. So y equals cosine of x. What does that graph look like? Well, we've seen this before. So here's our x and y. So cosine starts at 1, dips down below, comes back up again. And we know that that repeats at 2 pi. We know that in the middle is pi, and then those points happen at pi over 2 and 3 pi over 2. All right, so this is the shape of the graph. Our goal is to convert this thing into something in polar coordinates. Like this. So we have to think about which points we want to try to connect. And so what we're going to do is we're going to think about this part right here. We're going to actually think about this going from 1 down to 0. What does that mean for us? In this case, in order to give myself space, we're going to say that that's 1/2 and this is 1. And that's just to make the graph a little bit bigger. Okay, so what does that mean? So this means that when the angle is 0, in this case the theta is 0, the r is equal to 1. So we can actually make the little chart down here. We have theta, and we have r. Theta is equal to 0, r equals 1. And if we think about the key values of this thing, pi over 2 is going to give us 0, pi will give us -1, and 3 pi over 2 will give us 0 again, and then 2 pi will give us 1. All right, so this gives us a few points. Now, unfortunately, that's actually not quite enough to make this picture a little bit more apparent. So what we're going to do is we're going to imagine, let's see, so we have our first point, 0, 1. So 0, 1, that's this point right here. The next point that we have on our list is pi over 2 comma 0, which is right here. And a lot of students' intuition is just to connect those with a straight line. That's, a bad approximation. It is an approximation, but it's not good enough to actually show you any detail of what the shape is. And so what we're going to do is we're going to think about a couple of values in between. And the exact values we use doesn't matter. We could actually go in with a calculator and calculate exactly at pi over 4 or pi over 6 and pi over 3 and things like that. But the idea we want to use is that the graph from here going down to there starts at 1 and gets smaller and smaller and smaller until it gets to 0 at pi over 2. So the angle 0 here, the angle pi over 2 is here. And so I've drawn in these extra lines, and basically we're going to start at 1, and we're just going to go from each of these rays going out. We're going to go shorter, shorter, and shorter, down to 0. And so you can see we kind of get a shape that goes like that. Now, what happens between pi over 2 and pi? So pi over 2 and pi. Well, the values here are negative. What does it mean to have a negative value for our polar coordinates? Well, instead of going forward, we're going to go backwards. And so from here to here, we're actually going backwards. So up going backwards is down, left going backwards is right. So we're between down and right. And so we're going to extend this out, make more points there. The values are going to start from 0 and work their way to -1. So here we are at 0 at pi over 2. And as we keep on extending outward, we're going to get larger and larger and larger until we get 1. So the first one that we get, so we rotate a little bit, that corresponds to this line right here. It's going to come out a little bit. And then the next one is going to come out a little bit more, out a little bit more, and then back to here. And so we can actually see that we're building a shape out of these points. And a very difficult process. It takes time. But what you want to do is you just want to sort of think point by point by point, what's happening to the radius? Is the radius getting smaller or is the radius getting larger? And if you plot those in-between points, you will get a rough picture of these graphs. Here's another example. Graph r equals 2 sine theta plus 1. Now, just as with the previous one, we're going to start off by thinking about this as xy. Y equals 2 sine of x plus 1. What is that graph? Well, the plus 1, that tells us that our midline is here at y equals 1. The 2 is the amplitude, so it's going to go up 2 and then down 2. So it'll go from, that's 1, so that's 3, and that's negative 1. And this is a positive sine function, so it starts at the midpoint. It's going to go to the peak, back down to the middle, to the bottom, and then back up to the middle again. We know that right there, that's going to be 2 pi. Right there is pi. That's pi over 2. And that one is 3 pi over 2. So this is our setup. This is where we're starting from. Now we can notice that in this particular graph, there's another interesting point that we're going to run into. Where the graph crosses 0 is an important point that we're going to need to look at. And so we can go through the process and actually find out exactly where those things are. But for what we're doing in this class, I'm just good enough with you guys knowing that it crosses through 0 and showing that on your graph. And so what we have is we have our key values, 0, pi over 2, pi, 3 pi over 2, 2 pi. Our key values, our r values, are going to start at 1, go to 3, back down to 1, negative 1, and back to 1 again. And the important thing here is that it crosses 0 somewhere. And we're going to see what that's going to do to our shapes. Let's take a look. So let's plot our coordinate grid here. Okay, so when theta is equal to 0, r equals 1. So theta equals 0, r equals 1. So in this case, we have this as 1, 2, and 3, like that. When you get to pi over 2, that radius is 3. So pi over 2, radius 3. Now again, it's not helpful to draw a straight line from here up to here. You want to break up that interval into a bunch of pieces that work their way out to the value 3. You're starting at 1, and then at the next angle it's a little bit bigger, a little bit bigger, a little bit bigger, getting up to 3. So it has that type of shape. From pi over 2 to pi over 2 to pi, it's starting at 3, it's working its way down to 1. So again, we'll break this up into a bunch of pieces. It's going to get a little bit shorter, a little bit shorter, a little bit shorter, 1. Now here's where it's going to get interesting. Somewhere we're going to cross over to 0. We don't know exactly where, but the thing that's going to happen when we end up, when we get to 3 pi over 2, is that we're at negative 1. Well, 3 pi over 2, negative 1, that's 1 in the backwards direction, so it's going up this way. And so this time when we draw our values here, we're going to go a little smaller. At some point we're going to get to 0, and then we'll be on the negative side of things. And so this kind of loops around like this, getting shorter and shorter, then it gets to 0, and it goes into negative territory. On the last quadrant, it's going from 3 pi over 2 to 2 pi, and so it's going to be negative 1 at 3 pi over 2 to positive 1, and so it's going to get, same sort of thing. It's going to get closer to 0, and then work its way out to 1. And so you get a shape that looks like this. And so here's another example, and you really just have to play with this a little bit and try a few examples and practice this idea of plotting these points, making sure that you're thinking about how the radius is changing. And here's one more example. Graph r equals 2 cosine 3 theta. This is going to have some additional features that will come out of looking at the graph. So let's take a look. Here is our x and here's our y. 2 cosine 3 theta. Well, that's going to start up here at 2, and it's going to go down to negative 2. But this 3 right here, what's that going to do? The 3 is going to tell us that we're going to have more periods. It's going to vibrate faster. So the question is, well, where is that? Well, the normal period is 2 pi, and so we have 3 times theta. That's going to be 2 pi over 3 is going to be our period. Now we still need to think about our quarter periods, which is going to be 2 pi over 12 or pi over 6. So this is going to be pi over 6. I'm going to write that one as 2 pi over 6. That's going to be 3 pi over 6. This one's going to be 4 pi over 6. And this pattern is going to repeat. It's actually going to have another one. So 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6. In fact, in order for us to get to 2 pi, we have to go through 3 full cycles of this. So there's 2 pi. We have to go through 3 full cycles because it's been, well, the vibrations are increased by a factor of 3. So here's where it gets a little bit tricky. What does that look like in terms of our graph? We need to pay attention to where we're crossing over 0. That's sort of like one of the key factors that lets us think about what's happening here. Okay, and another thing that helps in this case is that our quarter periods are going to be at pi over 6s. So we will draw the pi over 6 values. And this is an example where the previous experiences will help you to see these parts without having to draw as much stuff. So what do I mean by that? When theta is equal to 0, the r value is equal to 2. So 0, 2. By the time we get to pi over 6, that thing needs to come down to 0. So it's going to start off at 0, angle 0, and pi over 6 is this first one, pi over 6. And so it's going to get shorter and shorter and shorter down to 0. And so I'm not going to draw it in because it makes it look real messy, but you want to imagine drawing a line from here out to there and thinking about where that point sort of is getting shorter, where that line segment is getting shorter. And it's going to come down kind of like that. What happens next? Well, between pi over 6 and 2 pi over 6, we're negative. So here is pi over 6, and here's 2 pi over 6. But we want to think about the negative direction. So if we extend this one through this way, extend that one through this way, we're going to be between here and here, and we're going out from radius 0 back to radius, well, negative 2, so out to the circle of radius 2 like this. Get this shape here to that shape there. From 2 pi over 6 to 3 pi over 6, we're still negative, so the negative 2 pi over 6 is down here. 3 pi over 6 is straight up, so we're going to be moving in towards 0 as we get closer to straight up. And this is kind of how we build these patterns. We just kind of have to think segment by segment, what's going on with the radius? Is it getting larger? Is it getting smaller? Is it going to 0? What's happening there? And as you keep working on this, what you're going to discover is you're going to discover that a pattern will develop. I'll do one more. So between 3 pi over 6 and 4 pi over 6, the radius starts at 0 and works its way out to 2. So it's getting longer and longer and longer out to 2. And so the pattern now will start to repeat. In every pi over 6, if it's at its extreme end, it's going to go down to 0. And then, let's see, so 5 pi over 6 going negative is going to come out this side. It's going to come out over here. And 6 pi over 6 will be at negative 1. 6 pi over 6 will be at negative 1. That's this point right here. And so you can see that the shape we're getting is kind of this what's often called a three-leaved rows. So you can see 3 little leaves here like this. These shapes are not as easy to draw. They take a little bit of time and practice. And really comes down to understanding this behavior, this up and down behavior, going out to some radius, coming back into radius as the angle is rotating around the circle here.